Recording is on.
Okay, well, welcome all to the March 4th, 2020 session of the Ontology Summit. The topic this year is knowledge graphs. I'm Gary Bergcross. I'm an Ontolog board member, and I'm happy today to introduce Paco Nathan as our featured speaker to add to and enlighten us on the knowledge graph topic. Paco has an MS in computer science from Stanford University, where he studied under Doug Lynott, which is worth noting. He has some core experiences, but really has multi-core experiences that include data science, training at Stanford for starting, natural language processing, machine learning, which I've heard him speak about very artfully, and cloud computing. And this is all as part of a 35-year plus years of industry experience. That experience ranges from work at Bell Labs to early stage startups, several of those. And he's now described provocatively as a player coach with Derwin Incorporated or Derwin.ai, but he's also playfully labeled as an evil mad scientist on his LinkedIn page, where artisanal cheese making is also listed as an interest. So, you know, we can cover a lot of topics today, depending on there may be some interesting questions there. Now, Paco is an advisor to several tech organizations, including what I'll talk about today, the NYU Coleridge Initiative, and he has advised IBM data science community and Anyscale, and there's more that you can read about on today's session site about his background. I note also that he was director of the learning group at O'Reilly Media from 2015 to 2018. And also, like last week's speaker, Anna Ruth, it was interesting to hear Paco talk about knowledge graphs at the recent January Earth Science Information Partners workshop, which was held in Bethesda, Maryland. Now, this week, we will get a little bit closer, a look at, from the knowledge graphs perspective, why for knowledge graphs and how knowledge graphs, adding to the knowledge representation perspective that John Sauer provided in our first session earlier in the year, the fitness information perspective of Matthew West, and last week's Anna Ruth's explanation of how to explore knowledge extractable from knowledge graphs. And I note all of these presentations and recordings as well as chat are available online. Paco's talk is interestingly titled Rich Context Knowledge Graph, which is intriguing to me at least, since last year context was our summit topic. And with that, let me turn it over to Paco.
Thank you very kindly. I appreciate the kind introduction. And I'm really grateful to get to present this forum here. Is very much our focus on the work that we're doing on rich context at Coleridge Initiative. And I want to go through some details and again, with respect more toward the knowledge graph representation and use cases, digging into that deeper than, say, we did at the ESIP winter meeting. And for what it's worth, you know, there's a funny story about the evil mad scientist thing. I have a good friend and colleague, DJ Patil, formerly chief data scientist for the United States, who used to be at LinkedIn, and we'd both tried out for the same job, and for whatever reason, he actually got a better job at the last minute, so I took the job. We stayed friends and compared notes. We were right down the street, and one day he was giving a demo to his execs at LinkedIn, and I was teasing him and had changed my LinkedIn title to Evil Mad Scientist. And anyway, it played out well. They loved it. They asked me to always keep that on LinkedIn, so I have. You've got some background about me, but let me focus on what's going on with Coleridge and how we got into the knowledge graph business. Just as background, there is a platform called the ADRF, the Administrative Data Research Facility. And this has been built out by Julia Lane. It's hosted out of NYU Wagner in Brooklyn, out of the cusp part of Wagner. And this is in answer to some of the problems encountered with working with data sets, especially sensitive data sets from government agencies, with the caveat that typically any use of sensitive data is typically joined with other data. So you might see microdata about individuals and some sort of social issues, income, epidemiology, I don't know, parole rates, things like that. They're just social issues. But you typically see the analysis of this where there'll be joints with geospatial data so that they can do segmentation across different community areas. So, I mean, even though a lot of this was originally pointed at, again, more of the social science side of it, we see in practice where there's a lot of use of geospatial data. So the ADRF framework is on FedRAMP. It's FedRAMP moderate compliant, and so that runs on GovCloud. And currently, well, this says 30. There's actually now 50 since I made this slide. 50 agencies at federal, state, and municipal, large city, local area. So the problem was that prior to this, typically if you wanted to use sensitive data from a government agency, you had to go into a secure facility. They make sure you're not carrying any USB sticks on you, and there's a security guard, and you work on a terminal, and you can't take anything with you. You can query the data. And in reality, as we're seeing, for people to really make the best of what's happening with these data sets, you need to join across different agencies. And so this allows for analysts and researchers to work across agencies in the cloud, work in a collaborative team-based session, and also gives a lot of feedback to the data stewards who are making sure that any access is according to data use, DAUs, non-disclosures, etc. So there are a variety of federal directives. I'm not on the policy side. I'm a machine learning person, but I'm aware from the policy side that certainly this speaks to concerns from the Evidence-Based Policymaking Act, Information Quality Act, Federal Data Strategy, etc. And again, I'm not the expert on the policy side, but there's a good article about this from Wyatt Cash in FedScoop middle of last year. Now, the context in which we're working, which is really kind of the lead into the knowledge graph part of this, is that there's definitely the framework component of being able to get access to data. There's the interactions with data stewards doing authorization and monitoring. There's also feedback to the agencies of how much their data sets are being used and for what kinds of use cases. And so, we have a lot of the nuts and bolts from a platform perspective. But at the end of the day, you're talking about people who are analysts at agencies or researchers, possibly working on a co-op agreement with some agency. So there's a lot of issues of collaboration. I mean, in addition to the security and privacy issues and compliance, there are issues regarding collaboration and training. And one of the points that Julia really made in developing this team and this initiative was that any use of the platform must be preceded by training, hands-on training with staff from the agency before they're onboarded. So really we can get a perspective on how people are collaborating, what kind of needs they have, really what are they expecting to do with the data, because a lot of times that's not very clearly articulate. And that's where knowledge graph comes in, because even though a lot of this data here is sensitive, the metadata about it, generally speaking, is public. And so we can track a lot of information about usage of data sets, how they're being used, by whom, what the use cases are downstream, even to the level of understanding the configurations that are used in, say, a Jupyter notebook that's being used to run a query and reshape a data frame, do some processing, do some analytics, possibly train a model, things like that. So the point there is that for the sake of training and collaboration, and in particular, being able to onboard new people into analyst roles, whether they're in the government or again, some academic lab that's collaborating with government, being able to train people and help them understand and work with data sets with which they're not already familiar, there's typically a lot of learning curve, and there's a lot of turnover in those roles. So we wanted to find ways to leverage the metadata and support the collaboration and training missions, cut down some of those training costs, and also just make the whole process more effective. And so that's where we get to the point of knowledge graph, because effectively there are links in the data. You rarely use one data set in isolation. You typically join multiple data sets. So already there's a linkage there. There's the linkage out to any published research. And then from that, of course, published research links to authors and affiliations, persistent identifiers, topic hierarchies, etc. And ultimately, can we use linked data and graph-based techniques to trace the linkage from the agencies that are collecting and managing data all the way out through the research, through the dialogue, out to sort of the end use cases, whether that's in commercial use cases or in terms of public policy. And definitely we see that at the federal level, state level, again, a lot at local level as well. So lofty goals, but definitely there are some ways in which knowledge graph appears to be indicated as probably one of the better tools for this kind of work. And there are other precedents. We are collaborating. We have our colleagues over in EU, and we've been working closely, actually funded in part by Deutsche Bundesbank. Their effort in this area, as far as research data centers and understanding metadata, linked data about dataset usage, that was really sparked in response to the 2008-2009 global financial crisis, and in particular, the 2009 impact in Europe. One of the resolutions coming out of that from EU was that they were going to look at a much finer detail of banking data, individual banks' microdata, and collect it, anonymize it, make it available for researchers so that, again, more research could be going into trying to preclude the conditions that led up to the financial crisis. And so they've been using knowledge graph techniques in Germany, primarily Frankfurt here, to understand use cases for data sets, since they, Bundesbank is in this odd circumstance of where they collect the data, they publish it. They also have a lot of researchers internally and fund and support external research. They also publish researchers. They have a large set of working papers. And they're also consumer in the sense that the governors of the central bank, whenever they give a speech, updating policy, they have a legal requirement to make citations back to the supporting data sets. So in terms of metadata, they have a richness with which they can draw. They've been using this to develop what they call a data impact factor, where they can see, relatively speaking, metrics to compare the relative importance of different data sets and activities at the federal level to collect those data sets. And there's a really great talk by Stefan Bender, Hendrik Dahl, and others, our colleagues over there at Deutsche Bundesbank, and really appreciate working with them and trading ideas with them, and also effectively trading open source. We're working a lot in open source, so we can work across the lines there. So our approach has been to really try to make the best of both what's available in terms of technical and human expertise and insights. Certainly, there is the aspect of creating a secure platform and working with federal agencies, USDA in particular, we've been working a lot with to develop out this process. But then, there's also the operational aspects. We have a team that is providing support for this. Certainly, there's a lot of ongoing work in terms of security audits and developing out the cloud-based services to support these kinds of analysis as they're scaling as well. And you get into the legal and policy issues, but really, what can we do to support the kind of decision making that's needed? And so, pulling back from that and looking at where knowledge graph comes in to play here, a lot of our end goal is toward again, as I said, that collaboration, training, and use cases regarding search and discovery. How can we make it simpler for social science researchers, agency analysts, et cetera? And also, how can we incorporate telemetry that's coming off of their work with ADRF, log files, et cetera, that we can use as feedback to augment the knowledge graph for operational statistics, for instance. But then at the end of the day, how can we develop, take these assets and develop recommender systems based on the graph to help accelerate research and training? Another goal that needs to be described up front, it really varies from agency to agency, but certainly there is the matter of federal agencies will collect data sets and maintain them, and then the data gets used downstream. It may end up in, for instance, there may be geospatial data that's being used in a smartphone. Whether or not the agencies know all of the links of how it gets there, I know that's an open question. But can we use this work in the different feedback loops and metadata, et cetera, to help to identify really what's happening in between? Where are the communities of experts who are engaging with agency data? How can we help identify people with specific expertise? So even though we're talking a lot about AI and automation, ultimately it comes back to people, helping people connect with the right people, learn the things they need to do. And from my perspective in machine learning, one of the more long-term goals here is, currently there's this kind of narrative arc in machine learning where we're looking to leverage machine learning to make machine learning more effective. And so certainly there is the different areas of AutoML, whether you're talking about augmented or semi-automated means for data preparation, whether you're talking about automating or even analyzing, giving feedback about feature selection, whether you're talking about hyperparameter optimization, model selection, ensembles, scaling, et cetera. There's a lot of different aspects of where the art of working with differentiable gradients and mathematical optimization thereof, that is to say machine learning, can be applied to machine learning workflows. And what we're doing with ADRF and with rich context is, in a lot of ways, from that perspective, collecting configurations that can be used as training data so that our recommenders ultimately can be making suggestions about configurations when an analyst starts to do their work. And this is coming under the general heading of what's called meta-learning in AutoML, a very active area of research, not clearly defined yet. Certainly, if you want to get a paper published, it's a great area because it's still very nascent. But we do believe that more long-term, we can feed into that as that area continues to evolve and open source solutions come available. So, rich context is the knowledge graph part of ADRF and Coleridge. And our focus, identify findings and results consistent with agency missions, really pointing toward evidence-based policymaking, decision-making. I should acknowledge that we are funded by institutional funding from Alfred P. Sloan, Overdeck, Schmidt Futures, and some others in the works. And we have been working closely with Deutsche Bundesbank, USDA, and others, also NSF. And there's collaboration with different organizations in scholarly infrastructure, since this has a lot of adjacency to what's available in scholarly infrastructure. So certainly with SagePub, Repic, Digital Science, ResearchGate, and others. And here's a visualization of a view part of our graph where we're showing agencies, which are producers, in orange, data sets in red, different publications that are linked in blue, the authors are in purple, and the journals are in green. We're adding a few other kinds of entities to the graph. That's pretty much the shape of what the main entities are. So bottom line, my boss's directive is that we're approaching challenges that most empirical researchers face. For a given data set, who's worked with that data before? what methods, what code configurations were used, and really what results were produced. Because if we can link those, then we can provide recommendations that are helpful for new people to come. Knowledge graph fits in with this because on the one hand, it provides a lot of flexibility for metadata representation. We're going into this without really knowing what, at the end of the day, the systems will look like. We came into this from the point of taking agencies and data sets, metadata about those as ground truth, and seeing what else can be linked to it. In some cases, those links must be inferred through machine learning models. So flexibility was a very strong component of our requirements. Also, along the way, we do have to be very mindful about metadata quality. As we are gathering metadata to add into our knowledge graph, much of it is available from public sources in scholarly infrastructure APIs. We do find problems with quality rates from some of the different providers. We really don't believe any individual source. Rather, we have a policy of attempting to triangulate, if you will, in any case where we take metadata sources, metadata from multiple sources, compare them, and then can at least establish some kind of quorum or consistency checks to be able to distinguish. And of course, also we do have means for manual override when we do identify metadata errors that are persistent. The rest of us have probably talked about many times already. Going toward machine learning models, recommender systems as products of this process. Knowledge graph is very good for representing the features that go into training models. And then also support for the end use cases where there may be end users that need to query the graph directly. Now, in terms of how this is being done, that's the part that's really fascinating to me, because there's not many good sources yet of how do you build a knowledge graph. And as somebody who's been a practitioner in this field for a long time, I'm somewhat baffled because when you talk with people about machine learning, they'll regurgitate all kinds of facts and figures about deep learning and press releases they've read from vendors. If you start asking about knowledge graph, you usually get blank stares. Somebody might say, well, Google's done that. But as far as the practice of developing graphs for knowledge representation, I think we're, unfortunately still in early days, even though we, arguably it's 5 decades later, we're still in early days. So I'm really curious to see and compare notes with many other teams about what is their process and how do they go about having a team do this kind of work. We do our work mostly in open source, mostly on GitHub. And we try to be very transparent and open about our process, and we're very happy to share that with other people. Also, of course, we are very mindful about attempting to use persistent identifiers wherever possible. DOIs for publications, ISSNs for journals, RORs for affiliations, organizations, ORCIDs for authors, etc. And we definitely are very interested to support these activities being extended. For instance, there is a lot of dialogue about persistent identifiers for data sets. So I very much want to be engaged in that. We do find that when there's missing metadata, these are opportunities to use machine learning to do inference and effectively link prediction. And we do make a lot of use of that. And we've had some very, very good results, I believe, or very encouraging results, I should say. We're also producing open source to federate discovery services across scholarly infrastructure APIs. I'll show that a little bit more. And through that process, we hope to be able to provide feedback to the scholarly infrastructure providers, suggesting corrections for metadata errors, etc. And again, this is taking into account what humans and machines both provide. In addition to the machine learning and automation, we do make ample use of different kinds of human-in-the-loop mechanisms, whether we're talking about active learning or weak supervision, manual override, etc. But how can we build feedback loops to help enrich and augment the graph? Simply stated, that's one of the main goals. And certainly, there's a lot of library science that goes into this effort. I think, in some ways, it's having the background in ontology, of course, is very helpful to understand how not to reinvent the wheel or commit the mistakes of the past. We also find there's a whole lot of need to understand DevOps and sort of the ML ops view of more of the nuts and bolts of the engineering, but also library science. A lot to learn there, a lot of overlap. So we relish the opportunity to work with librarians. I like to use this. I will give credit on this to colleague Ian Mulvaney, really talking about how you can look comparatively at activities, outputs, outcomes, and then try to measure the impact for any given activity. Certainly, we know about curated data sets. We understand that there are research projects, even though they may not be documented quite well. But the outputs of that are published research, and those are tangibles. We can use machine learning models to infer links between, possibly even inferring placeholders for research projects. If they aren't known, we can at least see where there are co-occurrence of authors who are publishing together and probably have a research project. But then we're concerned about this later stages of measuring outcomes to impact. So how do we track the linkage between published research and really, is this benefiting science or education or government? How do we measure behaviors there? So that's a lot of the question that we're coming into this with. And along with it, who are the experts? What are the topics that are emerging? What kind of methods can be shared? There we go. So let me give you a kind of an idealized view of how we build out our graph. So from initial stages, again, our ground truth is taken to be who the providers are and formal definitions for the data sets, with the caveat that the term data set itself is somewhat slippery. When you say data sets, does that mean a given database, or is it a collection of files and metadata? There's also the issue of, are you making distinctions of data sets based off of year ranges or geospatial segmentation? A lot of this comes to play in the kind of research that we see and we try to model. So we have to make some judgment calls about what is or is not a data set, and we review that and iterate on that. But we take that as ground truth. From there, there is both manual curation and also inference by models. Essentially, we have a lot of graduate students employed working on labeling, and then we use that ground truth to train models to do inference. But we can, by that, construct linkage between data sets and publications. And even though there is scholarly infrastructure making press releases these days, I won't name names, but several are talking about providing metadata about links between data sets and publications. When we press them for examples, we usually hear back the similar answer: wait a little bit, let's talk about that next month. Yeah, we're in development. We still haven't seen a lot of tangible. I mean, I'm hopeful that this is coming out soon. And certainly there are some resources out of the Scullix side of OpenAir, Dimensions. Let's see, what's some of the others that we've been in conversation. Oh, Datasets, certainly a lot of good work toward this, but not a lot available just yet. I think we're on the cusp of that. But once you start to link between data sets and publications, two things happen. One, since that linkage wasn't there before, now you can make a much richer graph. Two, you really start to blend different bodies of ontology. Certainly there's the DCAT family of how do you represent data sets and providers, but then there's maybe the CITO or other types of representation. How do you represent citations about publications, journals, authors, etc. So that's the first step bridge we had to cross. And then from there, once we do have representation about publications, we can link out to authors, affiliations, topics, methods, etc., and ultimately out to policy. I mentioned before there are different types of persistent identifiers on which we try to use as much as possible. It's not 100% coverage in any of these, but we are seeing a lot of good indications toward more standardized adoption of these. And so for every entity, we attempt to have at least one kind of persistent identifier, as well as mechanisms to make use of more than one type of identifier. Now, in terms of metadata representation, in terms of ontology, again, you get into having to blend what comes out of data catalog, and then blend what comes out of scholarly infrastructure, and then link that into the different types of subject headings. So it gets to be interesting in terms of graph representation, making sure that these parts all line up, and some of the harmonization matters there I could go into more details about, but I think that's fun. It is hard, and I empathize with anybody having to do that. Now, there is the point of getting people involved and being able to improve metadata. I'll talk about that in a bit. Certainly part of the feedback loop's involved. And then ultimately, how can we leverage this to start to quantify impact, really tracing that linkage from data sets out to policy. Another point that I've been talking more about lately, I'm also a lead committer on another open source project. It's called PyTextRank, and a lot of my background is in NLP. And yeah, I don't know, for those of you who've been doing work recently in NLP, you're probably aware that, over the past few years, it's just gone through this incredible renaissance. On the one hand, you have all the work racing toward these enormous deep learning models. Transformers is the basic class, also called Sesame Street, for Bert and Ernie and Elmo and all the rest. And you get these enormous models. Some of the latest have come out beyond billions, multiple billions of parameters for some of this stuff. Carbon footprints that are the lifetimes of multiple automobiles plus all their fuel consumption. So you get these enormous models going on for NLP, and a lot of incredible research being published. On the other hand, you get some very effective, lightweight, very fast graph-based methods that require orders of magnitude less resource. And so Spacey is a Python library, highly opinionated Python library. That is to say, it has what it needs, no more, not the kitchen sink. Very popular. I love working with those folks. I've recently become a committer. Well, I shouldn't say that. I have had a pull request accepted, which was made my day, if not my year or life. PyTextRank is a pipeline extension for Spacey to inject graph algorithms to extract entities and do effectively entity linking. And in contrast with, say, named entity resolution, this is a much more lightweight and, generally speaking, more effective way. It can build on top of NER, certainly, but it can also leverage knowledge graph to be able to constrain and focus what's being recognized out of the raw text. And then on top of that, since it is effectively working with graphs, you're building graphs in the process, you can sort of flip it backwards. So if you have this kind of NLP work along with, say, some graph embedding, some kind of vector embedding out of the graph, you can turn that back and begin to use the process in reverse, for some automated knowledge-based construction, effectively building the graph through semi-automated means. And so these are the steps that we go through here. Definitely, this is where the federated discovery services come in very handy for us to be able to scale our graph and then be able to use embedding models as oracles to extend it. Also, there's a lot of noise, of course, that's injected through automated means. So there are different means for pruning. I've been working a lot. If you haven't seen, there's a lot of work toward pruning on the node centrality side. That's kind of typical. But I think there's a lot of interesting work on the edge side as well in terms of looking at multi-scale backbones and disparity filters. And there's another open source project where I've implemented one of those in Python. And then speaking more toward the business side, the use cases and the personas that we're working toward would be, well, if somebody really is evaluating the impact of a data set on public policy, there may be questions. How is money spent collecting a data set? How has this been used? And what are the outcomes? And what can we do to contribute to understanding that impact? From the public perspective too, definitely there are requirements now for agencies to make their automated data inventories more available to the public, and not just toss a list out there, but actually provide something that's much more interactive and much more informative. And certainly, a lot of our use cases are analysts and researchers. The funders are very focused on how do they, over the long term, support the process of scientific workflows. How can we help to use machine learning and knowledge graph to augment that? So there are several open source projects. The main one that we have is called RC Graph, and so it's on GitHub. And then there are several submodules that are linked into it. The part about federating discovery services, the scholarly infrastructure APIs, that's on a project that you can load through PyPy or Anaconda. It's called richcontext.scol API, and it currently federates about a dozen different scholarly infrastructure APIs. We're adding a lot more to that in terms of some automation, reflection, some machine learning supported measures of metadata quality, measures of performance, coverage from different data sets across different properties coming out for entities, support for precision identifiers, etc. So we hope to publish about that, some of our measurements across different APIs. I think that can be useful for the community. We also have a machine learning competition where we take our graph and publish it, and then have machine learning teams across the world, a lot out of academic departments, but there's been a leaderboard competition to perform particular tasks. For instance, I mentioned about making inferred links from data sets to publications. What data sets were required for the research described by the publication? And so currently, even with a baseline model, we're seeing supervised models perform at approximately 80% precision for top K analysis, which is pretty good. I mean, that's metadata that didn't exist before, and it's very useful for us. And then for unsupervised methods, effectively being able to detect and suggest data sets that weren't known before but are mentioned by the research. The accuracy rate is lower, but that's improving, and there's a lot of good use for deep learning Q&A systems for that. Those rates are more 60, 70% still. But we're adding a lot to that, and there's a whole new body of features that have gone in. We hope to see this more toward the high 80s, low 90s within the next 6 months. And I'm going to scoot through the rest of this a little bit more quickly. We have been involved in supporting Jupyter for the past couple of years, helped on the funding, securing funding for additions to Jupyter Lab to support dataset registry, metadata explorer by linking into resources from a knowledge graph, as well as collecting telemetry about usage. So these are extensions on Jupyter Lab that we've helped to build out, and certainly would love to talk to anybody who's interested in using these. For what it's worth, I'm co-chair for JupyterCon, and we'll be having the next instance of that in Berlin in August. So if anybody's interested in going to JupyterCon and needs details, please ping me about that. Yeah, the machine learning competition, it's styled after, if you're familiar with NLP Progress or Papers with Code, that kind of leaderboard where the research is public, the corpus is public, the competition is entirely public, as opposed to things like Kaggle, where a lot of the intermediate results are, of course, held out privately. The human in the loop part is really super interesting. We've been working with Christian Zimmerman at Repic, and the idea is it's active learning. When we infer metadata, then if we have if the models have high confidence, take it. If they have low confidence, then we can kick that back to authors. So an author might get an email message that says, "Hey, for this paper you published, we believe that these are the data sets were used. Confirm or reject. Click the button." And places such as Repic, which have a lot of high touch with authors for a particular vertical, we've been working with them to reach out to the author communities. It's great to have that expert feedback. Also excellent to be working with agencies and bringing in AI teams from outside to collaborate on the problems on behalf of agencies. And some of the benefits there I think I've gone over before, but really working toward characterizing the impact of data, understanding their communities, getting feedback. And if you would like additional information, we have a book about this, which haven't heard from the publisher recently, but things were very busy at the start of the year. So we expect to have this published within the next couple of months here. There's also some other articles and talks which have been done by our team and our partners recently. And if you would like to get a hold of me for any other reasons, here's my website, and Twitter is usually one of the best ways to reach me. But having said that, let me go back to showing what the graph looks like and see if there's any questions. Thank you.
Well, thank you, Paco. That was really great. There's a lot of enthusiastic response on our chat page, which you can turn to. And what we normally do here is that people have the ability to raise their hand, speak up when they get unmuted, and ask a question or make a comment. And so we'll take it from there. We have our usual first response from Ravi, who always has a question or a comment. So with that, let me turn it over to Ravi and see what he has to say.
Hello, can you hear me?
Yep.
Yes, hi, Ravi.
Yes, Paco, just a couple of basic questions. You did show us a couple of slides on how you make the knowledge graphs, but is slide 9 the picture that you show, the image, is that a knowledge graph?
Let me
Slide 9.
Slide 9. Let me go back to the view there.
That is a rich context. Do you use rich context to make the knowledge graph?
Yes. Let me get back to the slide there. Sorry, I took it off of the full screen mode.
It's just called rich
yes.
context.
Yes, I understand. Let me work with my screen a bit because I had one view that was stuck in full screen and we couldn't see it. Okay, slide 9 is where, let me go back to that. Yeah, there's a visualization of the graph. And that's just a PyBiz. It's based off of biz.js doing a visualization. But that is effectively a visualization of the graph that's represented symbolically on slide 19.
Slide 19. Okay.
Yes.
Not 9.
Well, 9 is, like I say, a JavaScript rendering of doing a force-directed network diagram. But the discussion of the entities is on slide 19. So those are effectively the same thing. One is empirical, the other is symbolic.
Okay, and the second question is, do you use NIEM when NIEM when you communicate with agencies using common vocabularies?
Very good, very good question. You know, I mean, a lot of that has been evolving. We started out from what would be called air gap kinds of practices. What I was describing, where you go into a dark room with a security guard, and hosting air gap ingest, and then you know, we're subject to a lot of security, penetration testing, things like that for compliance every time we do a software release on the ADRF side, not on the rich context side. So as far as the ingest process, that had been adapted originally just to make sure that we've got all the security compliance, privacy compliance in place, because that's such a priority. But now we're starting to adapt more toward how can we leverage standards to make that ingest process faster. So NIEM is very much in category. We're trying to evaluate that, but again, the security auditors lead because of the sensitive nature of the data.
So this is Gary again. We're waiting for other people to raise their hand, but I did have a question. If you could say a little bit more about how machine learning is used to create missing metadata. Maybe
Great.
you can give an example or two.
Oh, certainly, yes.
Good one. Good question.
Yes. Great question. So there's a few levels of that. I want to make sure that we understand we're talking about multiple kinds of modeling, different stages of workflow. So the thing that really is core for us is, there does not exist yet a good, reliable source with wide coverage where you can go take a DOI, look up a paper, and then find out what data sets were required for that research. However, typically when you look at scientific papers, oftentimes in the methods section, oftentimes in other sections, the authors will, of course, make mention of which data was required for the research, which data sets they used, possibly other information about versioning. So we've hosted an ongoing machine learning competition to develop models to detect data set mentions and then classify them, whether they're just discussing them in passing or whether they're actually trying to state that this research relied on that data set or that set of data sets. So that's where the human in the loop part comes in, because once we've inferred that, then we can run those inferred results back across sets of authors to get them to confirm or reject what the machine learning models produce. So that's one area. But even stepping back from there, another hard problem is the preparation for that modeling. How can you take the text that's extracted from an open access PDF of a paper? How can you perform the necessary NLP to be able to build those kinds of machine learning models? And that's where we get into some current work in weak supervision. I don't know if you're familiar, but in terms of PDF parsers, it's very arcane and very specialized, very hard problem, thanks to some of Adobe's practices. But the idea is that a research paper typically has headings such as introduction, there's probably conclusions, there's probably a bibliography or references or citations. And so weak supervision is a good way of being able to categorize the sections of a paper, which refines how we do the parsing and inference based on the text content of the paper. So for that, we're working on models in Snorkel to do weak supervision for effectively the label functions. I'm a real big fan of weak supervision. And then there's some other areas of machine learning as well. For instance, in terms of improving our topic modeling that's derived from not just keywords in an abstract, but from actual phrase extraction, as well as how can we distinguish between different authors, resolve ambiguities about author lists. So there's several areas where machine learning comes into play. Does that help answer the question?
It certainly does. Thank you. So we have two hands up. The first is Todd.
Actually, Leah was first.
Oh, okay. So we have Leah Dickerson was first.
Hi,
Leah.
Paco. This is a fantastic presentation. Thank you. I am a librarian and had two questions for you. One, as a librarian, I was interested in you talking specifically about what type of tasks that you rely on librarians to assist you with. And then two,
Great.
I saw that you had a use case for a congressional aide or auditor. I work at GAO, so that was very intriguing to me. And I was wondering if you could talk a little bit more about that use case and how you were working on fleshing it out.
Great. Well, for the first question, where do libraries come in? So we do need to be able to ingest metadata about data sets. And in some cases, we're talking about data sets that are public. So can we work with, typically at the agencies, there will be some libraries to support how is the metadata being published, where there are systems for exchange or access to that metadata. And there are a lot of nuances there that have to be resolved. But more importantly, I also find that libraries are very good at being able to help locate domain experts. And so a lot of what we're doing sounds good on paper, but in practice, it really requires a lot of review and feedback from domain experts in multiple different areas. And to the extent that we can work with libraries to try to identify for a given data set where there are some known experts that we can bootstrap off of, it really accelerates our work. So that's in a nutshell, those are a couple of the areas. Now, as far as the use case going toward some sort of data impact, again, we're really bouncing off of some of what we've seen by our colleagues in Europe, who arguably are more sophisticated in this area. They're more advanced. They have federal laws that are more supportive of this kind of use case. So we're trying to learn from them, and also trying to just understand from more of a design thinking perspective, really who are the persona for our user experience, for the end use of working with this graph. And you know, when we talk about data set impact, certainly there will be the people who are looking from a government perspective. You know, what is the benefit for use cases of particular data sets? How are they being used together? Because again, they're very rarely, in our experience, very rarely used in isolation. So when I talk about maybe a congressional aid, that's our shorthand for a design persona, and trying to understand what do they want out of this. As far as getting toward data impact metrics, we do not have that yet. That's in progress. We're working toward it. We can certainly calculate centrality metrics to give some rough indicators, but there's also a machine learning model to how to weight elements of the graph, because not all the entities in the graph are created equally. So for instance, journals have been a real big distortion for us. If we link journals, what kind of weights do those edges contribute to any sort of metrics that are collected? So for instance, if you're looking at the journal of, I don't know, maritime resource usage or something like that, it's very specific. The journal links can contribute a lot. But if you're looking at you know, PLOS ONE or Nature or some kind of journal that just publishes everything but the kitchen sink, their contributions in the graph are actually kind of muddying it. So that's another area where I guess I'm getting a little bit far afield of the question, but that's another area where we have to be really careful about how we start to assess metrics, and another area where, you know, library practices very much inform us, but also some machine learning turns out to be required to handle this at scale.
Thank you so much. Yeah, that answers it. Thank you very much.
So, Paco, if you can say a little bit after the hour, we have some more questions coming.
Yes.
Yeah, so Todd, I think, is next now.
Okay, I'll make it short. I just have 3 questions. First, Paco, the first one is just for my amusement. In your video transmission, you have your camera pointed towards the ceiling. What's covering your ceiling?
Okay, so I'm located. We live up in the redwoods, out toward the coast in Northern California, and if you're familiar with the area around Sebastopol, Bodega Bay,
right?
And I'm actually. This used to be a bowling alley. In fact, the sign that says "bowl" is, you know, from the 50s. It's still out there. Downstairs is a Sebastopol ballet. My daughter is a student at the ballet school, and upstairs the office for the old bowling alley office was unused, and that's the insulation for the ceiling. If I turn this direction, you may be able to see sunlight through the corner of the wall. So my apologies for the background. It's rather industrial, but
well, no. I was mentioning because the room sounds very dead acoustically, so it's easy.
Yeah, it does.
It's very easy for us to hear you. So now the more technical questions. You used the term microdata. Did you mean a statistical term or the semantic markup? That's a proposal.
Really great question. In fact, that was the first thing that we put in our FAQ. The computer scientists come at this and they start to hear microdata, and they're thinking, oh, great, you know, we're working with embedded metadata formats and standards. The social scientists, of course, they hear that and they think that they're working with confidential data about individuals. So really, from the perspective of agencies, you know, talking about whether it's census or Bureau of Labor Statistics or any of these, when they've got microdata about individuals, and it may be very sensitive. It may have to do with salary or medical history or
So,
prison sentences, things like that.
but so how are you using the term in your work?
Oh, well, again, we're supporting research that is very much driven by public policy and social science research. So it's the latter. We're talking about microdata as opposed to macroeconomic data.
Right. And my last question, if you can answer it quickly, I know we're sort of out of time. How do you maintain or enforce semantic consistency given the scope of materials that you are fiddling with?
That's an excellent question. Yeah, that's the one that keeps me up at night. Yeah, it's difficult, and also we're working with people who really want to see the outcomes, and they're not concerned about the nuances.
Can you discover inconsistencies, if not maintaining consistency?
Yes, there are some ways that we can help to discover inconsistencies, and maybe that's at a coarser level, but certainly. So for one thing, we had to take a fairly sophisticated approach about doing string matching. And this probably sounds trivial, but when you're making judgments about authors, about dataset names and mentions, about titles of reports, of course, there's going to be a lot of collisions and a lot of garbage in the strings that comes out of some of these APIs. And so we've actually had to do some pretty interesting machine learning model, local sensitivity hashing and some other techniques to be able to calibrate our string matching. And
is that done
sorry.
Oh, sorry, I interrupted. Is that done in real time as part of your feedback loop or a posteriori?
That's done in batch. A lot of the workflow for creating, there's a multi-stage workflow, currently about 10 steps for developing the point of actually having Turtle and JSON LD. And then from there, there's another half dozen steps before we actually get out to the point of having open access PDFs that we can infer links off of and then put into a UI. So yeah, over a dozen steps there.
Do you ever rerun your, after you've processed some corpus of material, do you ever rerun it to see if something changes?
Yes,
okay.
Very much so.
Okay.
I mean, that's what the grad students are always hitting me with. Hey, we pulled this data before. Can we just keep it and propagate it, in perpetuity, so that we don't have to look at it again? And my short answer, no, because metadata changes. And,
no, but I was thinking of testing.
Oh, yeah.
Okay.
Oh gosh, yeah. No, there are unit tests, and I mean we use axioms wherever we can to some extent. Right. Haven't gotten a lot of purchase off that yet, but we use it some. But we definitely do a lot of consistency checks and unit tests.
I was thinking of system tests, whole system tests. You've taken your stuff and you run it through, and even though if you got done individual unit tests, when you put all those units together, sometimes, oops.
Well, so yeah.
Okay.
Kind of a fine point there. Basically, if you think of a pipeline or a workflow as a DAG, and having some feedback loops in it, you may have unit tests on particular aspects of it. But then at later stages, as you start to aggregate and do joins, the unit tests of those effectively become partial system tests.
Right.
So a little bit of a semantic there from computer science. You got me on that one. But just even coming up with this is really hard.
Oh yeah.
And from a computer science perspective, that's some of the really fun part of this is that area of harmonization and consistency, and being able to do some kind of inductive work on proofs. Really, ultimately, I think we did our work right. And always the answer is, well, probably to a certain level.
Right. Well, thank you.
Thank you.
So next, if you can stay for a few more minutes, Paco, we have a comment or question from Mark Underwood.
Great.
Hey guys, I think these will be easy. Is NIST part of the Coleridge Initiative?
NIST. Well, as far as data sets that have been ingested or working with trainings and all, I don't believe, although obviously there are a lot of publications and standards coming out of NIST that we take as canon because of the audits, the security audits, and the privacy. So to that extent, yes, a resounding yes. And in developing the white papers, I've had to cite a lot coming out of NIST. But as far as the actual data sets yet, I don't believe that's one that we've onboarded.
Okay, well, I'm curious because we're in the big data public working group and worked on a reference architecture for that. So I need to catch up with what you've done for that group. So that's cool. One of the
Wow,
thing
fantastic.
one of the thing is there, have you worked with clinical trial data sets? Because I thought the big pharma people had tried to work on this problem with them.
That's a great question. Well, so 2 points there. I mean, one is we definitely, and in fact, through ESIP, I know some of the people here are involved with ESIP. I've come into contact with a cluster. There are knowledge graph projects at various agencies, and we're very eager, still at early stages, to find out ways to do exchange and import and things like that. We're very eager to collaborate with any and all. I just wanted to throw that out there. And also, the second question, sorry, I know
Clinical trial, yeah, clinical trial data.
Yes, I'm aware that some really interesting knowledge graph work for clinical trials. Another hat that I wear is I'm involved with different conferences, and I'm often introducing talks, and and I've run across some of these. As far as, do we have clinical trial data included in there in any of the data sets, I'd have to look up. But I am familiar with, boy, I'm going to slaughter the name if I try to take it from memory, but I know there's a large one, I believe, based in Boston, and they had done a lot of work on harmonizing DCAT with some of the other controlled vocabularies that I needed. So actually, I used some of their presentations out of pharma to in some of the early stages of our representation work.
Great. Well, I'll share with you what I know about it, which isn't much.
Thank you very much. I look forward to talking.
This is Gary again. I have a question before we get to Janet, who may be our last question. I'm wondering about the ontology perspectives and what you might have to say from your experience about what useful ontologies there are, or what are the problems with finding a useful ontology and using it, how to use it here.
Thank you very much. In fact, let me bring up the page. If you, I'll have the slides available. I believe the slides will all be available. And where we talked about our machine learning competition, we actually there we have linked out. Let me dig this up. Actually, ADRF is going to be that one. So in the corpus for the machine learning competition, we do make a lot of formal links out, of course, in the JSON-LD. We represent it in both Turtle and JSON-LD. We make links out to the control vocabularies that we're using. And so that goes out to a project called ADRF Onto, and where we have our vocabulary. And let me dig that up. That is making use of several other resources on which we depend. Certainly DCAT, Cyto, Friend of a Friend, and others. One of the things that we really struggled with is I can't find a lot of good ways previously to represent data citations. There's some out of Cyto that we made, kind of bridging that. But we really found that these were typically two distinct bodies of ontology work, and we hadn't seen a lot to bridge between them. So I'd love to get any suggestions. We've made our best attempt at it. What we do, let me bring up our vocabulary. What we do though, so Cyto, DCAT, DOI, Fabio, FOAF. We will be making use of MadsRef. And we build this up into OWL, SCAS on OWL. And because it's discovery services, there's a lot of good benefits having this in SCAS, and of course a lot of others are using that. So those are some of the different types of vocabularies that we're blending, but we hadn't seen a lot of previous work blending those, mixing those, reconciling those.
Well, one of the issues for me is that sometimes the particular needs for semantic resources and particular ontologies are not made evident and come out to people who might work on them, so that when people are working with knowledge graphs like this, if part of the work could be sort of signaling we could do a lot more if we had a better ontology here.
I agree.
Forward.
I agree very strongly. So yeah, and case in point, On the one hand, we've been working with colleagues over at U Manchester. Carol Goebel has been very helpful for us, and a lot of her team and their resources, and their work on Taverna and PAV and research objects. Really excellent work. More pointed toward research. On the other hand, we've been working with industry. There's knowledge graph projects. Mark Grover has published about Amundsen out of Lyft. And there's also a lot of, Srishanka Das recently published about the work on warehouse leading toward now called Data Hub at LinkedIn. And there's also some work on, I believe it's called UMS at Uber. I've done other talks where I showed that in industry, there are maybe more than a half dozen examples from that class of like Netflix, LinkedIn, Uber, Airbnb, Lyft, etc., where they were struggling with compliance in the wake of GDPR and other regulatory standards. And so they came to the conclusion that since they make their money by leveraging data sets, they would have to build up knowledge graphs of metadata about data set usage. And so independently, these different firms reached this conclusion, launched these projects, and then started making them open source. And now they're at the point of possibly even having conferences. Srishanka was talking about having a conference for this. And they've made these projects open source. And when you go in and talk with them, one of my first questions is, okay, well, so what control vocabulary are you using? What kind of ontology? And you just get blank stares because they came at it from a very pragmatic industry perspective. Right. And as far as leveraging existing ontology, they didn't even know. And at best, I might get people telling me, well, we just use schema.org. That's fine. And like, that's not exactly an answer. I think there's a lot of way forward, a lot of road ahead for being able to do more formal work with ontology and blend it with all this funding and work from this category in industry. Because across the board, once they dip their toes in the water and start addressing compliance needs, and once they start getting more formal definitions of their data set usage, the next thing they realize is, wow, we could do a lot of cost savings. We've got a lot of wasted time rediscovering data sets that we already knew about, but didn't have a good way for somebody to search. Or they find maybe we can open up new business lines based off of knowledge graph, that what we can see. So I think that we're going to get a lot of momentum from this, not the Google, Microsoft, Apple level of AI in industry, but the next tier, the younger tier, sort of AI natives like Lyft, Uber, Netflix, Airbnb. They're going to push this, and they have a lot of resources, but they don't have a lot of formal training when I go and talk to the engineers doing it.
Well, thanks for the consciousness raising in the appropriate communities. And so let's turn to Janet finally.
Thanks, Gary. Yes, this is very good, and you. I don't know if you've seen in the chat. We've been very appreciative of your mentioning library science, and also one thing I really liked was you said, in effect, that we're 50 years in on this work of more effective data use using knowledge graphs, but that's still early days, and there's a lot to learn and a lot that can be done. That's an interesting perspective that we have. I guess it's gradually been emerging as we've proceeded through these discussions, that in the beginning there was a lot of frustration of knowledge graphs is nothing new. It's just, it's been around since the 70s. But now I think, contrasted with the hype of it's the new silver bullet and it's going to change everything. I think the perspective that you brought there is that 50 years in is still early days is really the answer. That it's not new. None of the things you're talking about are strictly new. They're machine learning improvements, big data. The technology has changed. Some standards have changed, but we should be looking at. We're working on this evolution where we're at an exciting point. But some of us who've been around since the 70s,
Right.
80s, should do a better job of putting everything in context, so that the young people can see what are the persistent problems beyond the terminology of the day, and where the thorny non-technical problems come up, as you said,
Right.
library science.
Right.
You know, if in the 80s, when I was, involved in the AI work to some extent, I didn't see people talking about respecting librarians, respecting library science. When the ontology stuff came up, I didn't see people saying, let's try to learn from what people over the eons have struggled with in ontologies. So there kept being a new hope instead of sort of the boring. The more we can go back to the boring old issues, the better off we are, I think.
Yeah.
Anyway, sorry, but so I made a speech, but I really appreciated your perspective.
Thank you, Jen. I appreciate it very much. One footnote that I'd add there. I mean, if you're a PhD student, you want to get your paper accepted by NeurIPS, you're thinking about spending hundreds of thousands of dollars on compute for some incremental improvement on a deep learning architecture. But if you come out with approaching these thorny issues, but extant issues from a long ways back about knowledge graph, where are you going to get your paper accepted? And I think that we really need to grapple with that. On the other hand, it's not just academic. I mean, I have friends who are doing this kind of work, for instance, for Airbus. Airbus faces a supply chain problem for all these different aircraft, all these different vendors, a lot of different database systems, and they have to spend significant amounts of time every year, downtime on their data systems, just to go back and harmonize the metadata before they can go and continue to do queries to get the vendors to do the supply for repairs. And that's a safety issue. I mean, that they're doing it well, but they're using knowledge graph for those harmonization problems because there's a lot of risk and billions of dollars at stake. And as we've seen with some other airline manufacturers, this is a real problem. And I've seen similar, I believe that General Electric had a knowledge graph. I talked to some of their people. I don't know what the current status is, but they have this problem with compliance, getting people who are trained appropriately to work on different product lines. You may have a lot of staff, but they may need, for compliance reasons, to have certain training before they can work on the line. So they have this graph that aligns product versus requirements versus training versus individuals. And I mean, these are real social issues in industry that we have to grapple with. It's not academic, and we can attach billions of dollars to it. And I think that as a whole, we need to recognize that and talk about that more.
Paco?
Excellent.
Yes.
Can I respond just briefly? And so I work more in systems engineering now with the International Council on Systems Engineering, and they talk about we need to improve systems engineering, model-oriented systems engineering, that kind of thing. But where's the money for library science, as you're saying? We don't have a grand challenge. We don't have a grand national challenge saying we have to address this library science problem. We have, as Mike Bennett's been pointing out, people they frame things either in terms of we need a new technology, or we need to address this social problem like poverty or something like that. Instead of, we have these massive inefficiencies from incoherence in effective data use. I'd love to see a moonshot on library science, or on what is essentially library science. So thanks.
I'm all with you.
Paco, one point of information, one final question, which you may not want to answer. Point of information. Well, point of information. You mentioned industry. There is an effort that was initiated by NIST and some people at Buffalo, particularly Barry Smith, and it's now called the Industrial Ontology Foundry. And we are trying to develop ontologies in a consistent fashion or coherent fashion that can be used by industry. And we do have people from Airbus participating.
Oh, great!
And yes, you can, if you look it up, foundry.org. There's a website there.
IOF, yeah.
The question I have for you, though, is some of the things that you called ontologies that you referred to, I wouldn't consider them as such, only because I'm sure they are very practical and they solve a particular problem, but they are not extensible necessarily, and they're not going to be easily interoperated with. So my question is, have you made use of, or do you feel there's a use of making, or feel there is a use in using foundational ontologies to help in the development? Not necessarily using them explicitly, but at least in the development, whether it's terminologies or whatever.
Oh, okay. So in category then, could we be talking about upper ontologies,
Yeah,
such
I
as
call
what are
them.
used for subject headings and that
I
kind
call them foundational ontologies, but no, for the analysis in developing your semantics.
Yeah. Well, no, I need to be more precise about terminology. My apologies about that.
That's okay.
I should probably be saying control vocabulary more often than ontology. But there are very distinct, very clear uses for or foundational ontologies, as you're saying. So, for instance, one of the things we find is when you try to make recommendations off of the graph that I was showing about the
Mhm.
kind of bibliographic links, if you will.
Yes.
If you don't have some rebalancing of the journals, if you don't have analysis of topic modeling, you get really biased results coming out, and it's not very useful. And so this is one area where the foundational ontologies can really come in with effectively standing on the shoulders of giants, reusing a lot of the learnings of the past. How can we link in to try to have some kind of rationale organization of our graph? Because without that, we end up in
Yep.
these very biased, imbalanced cases.
Okay. Well, thank you.
Thank
Good
you.
luck.
I'd love to. Thank you. I'd love to talk more about that. I want to learn more about IOF.
IOF.
Okay, well, we've run very far over the hour.
But it was fun.
Yeah, it was a lot of fun.
Thank you.
It harkens back to the time 30 years ago when I was extracting materials and methods from biology papers. Sounds very similar.
Very good.
But that's enough for this.
Yes.
Thank you, everybody. Thank you, Paco. That was
Thank you,
really
Paco.
Thank you, Ken. Thank you, Gary. Appreciate it. Thank you, everybody, for participating. I'm going to enjoy looking through the comments in chat, and I look forward to participating more.
And if you might annotate some of the things you've mentioned, we might have the spellings of certain things. So if you have time to actually add something, that would be great.
Great, I will do. And also, will the slides be made available? Because there are a lot of
They are.
links.
The slides are already available.
They are available.
The video recording will be made available.
Thank you.
And I want to invite everyone to come next week, and in fact, every Wednesday, to our Ontology Summit. And let's see, I believe quite a few slots have now been advertised.
Yeah.
So if you take a look at the Ontology Summit webpage, you'll find that next week we have Sagar Srihari, Hari Srihari, then Spencer Greiner, then Ernest Davis, and then on April 1st, we're going to have our first synthesis session. So see you all in the coming weeks.
Thanks, everybody.